So question 3, I don't think many of you will need to watch this video on this. After 2 questions on stuff that hasn't been taught yet, we've now got kinetic energy, and you're very good at this, as seen through your previous mock. So calculate the kinetic energy, it gives you the equation. So K equals half mv squared. So K equals 0.5 times 68 times 12 squared, 144. And that gives me my answer, 4896. Describe the energy transfers when a cyclist used the brakes. So if I've got a bike, dodgy bike here, but that'll do. It's going to have kinetic energy, and then I'm going to put the brakes on, and that's going to go to heat energy. And then I've just got to say, well, what happens to the level of energy in each? So kinetic energy will go down, heat energy will go up. So kinetic energy stores of the cyclist will decrease. The thermal energy stores of the brakes will increase. Done. But you can see I've put in capitals there, the decrease and the increase. I'm going to say what happens to the level of each of those stores. Next one, it says the cyclist starts to cycle again. They've got 1,600 joules of useful work. I'm happy with that, no unit change. And I need it for 28 meters. I'm happy with that, no unit change. And for this, we're going to need fat, wobbly dinosaurs. So we want to work out the average force. We know that work equals force times distance, as in the fat, wobbly dinosaurs there. So F equals the work divided by the distance, 1,600 divided by 28. I've worked out my force. And again, the tricky part is just remembering the equation. But you could quite happily have gone in and seen that I've got work or energy. Remember, work and energy are the same thing. And I've got a distance and it wants a force. So we can see I've just got to go and find a formula with F, W and D in it. Okay, next one. An athlete uses a training machine in a gym. We've got 2 displays. So they've used 45.2 kilojoules over 300 seconds in session 1. They've used less energy in 300 seconds in session 2. And explain what this shows about the power of each. Well, we can clearly see the power is reduced here. But for us to get 2 marks, we're going to have to say what power is. And in terms of last year, you're fab at this. So we're going to need PET, energy is power, times time, or power equals energy divided by time. And to get the marks, do the calculation on each. So I'm going to do the basic, power equals energy divided by time, do it for each. 45,200, I've just changed that into joules, divided by 300, 151 watts there. Then the power here, 37,900, divided by the 300 seconds, 126. And then I can just compare the two. So the athlete had more power in session 1, so did more work in the same time. And I can see it's the same time. They both did it for 300 seconds. So it's just making sure you use your power is energy divided by time. And that's that.